We'll try this question for a number of 16 bulbs. The initial position is off. So if this operation is repeated even number of times, like first person does it on and then again the second person does it off, so then even number of times the position of the bulbs remains the same, like it's off, and odd it will be changed. So we'll see that the first person does it on each bulb, so the second person will change the position of all the even number of bulbs. Again the person number 3 changes the position of the bulb. Number 3 is 6, 12, 9, 15, and similarly the fourth person for bulb number 4, 8, 12, and 16. And person 5 for 5, 10, and then 15. The 6th one will change for 6 and 12, and the 7 will change for 7 and 14. 8 will change for 8 and 16. And then similarly 9 will change only 9, 10 will change only 10, 11 will change only 11, 12 only 12, 13 only 13, 14 only 14, 15 only 15, and 16 person will only change 16. Now if we notice this bulb, the fourth bulb, the ninth bulb, and the 16th bulb, they all have been changed by odd number of people. 1 time, 3 times, 3 times, 3 times. So we know that odd number of people changes the bulb, the value changes. Like if it was off, it will become on. So if we observe 1, 4, 9 and 16 are perfect square. Basically if we check, all these are number of factors, and hence the number of factors in a perfect square is odd. So we are getting this result as a chain sequence for the odd numbers. You can see that. So in our first question, what is the final state of bulb number 64? As we can see, 64 is a perfect square. Then what will be the position of this bulb? It was initially off, it will be on. I hope we are clear here. So in the second question, how many of the light bulbs are illuminated after the 100th person has passed through the room? So how many perfect square are there till 100? So there are 10. So we can see that the answer will be 10. So the question number C, who is the 100%? Out of 100%, who is the laziest one? So from 51 to 100, all are doing only the least work. So anyone from 51 to 100 will be the answer. So for D, how many person has flipped the switch on 72nd bulb? So we just have to find number of factors, which is 12. So if we see the previous question, 100 per person and 100 bulbs. So from 1 to 50, there are 7 perfect squares. So all these bulbs will be on. So 43 off. And from 51 to 100, 3 perfect square. So these will be on. The rest 47 will be off. Total 10 on in this case and 90 off. What is happening here? From 51 to 100, if you see 51, 1, 3, 7 and 51 are the factors, but currently we don't have 51. So how many are the factors now? Only 3. So this will only be off, this won't get on because the factors will be still odd. This is true for all. So now from 51 to 100, that is applicable for every number. Each number will have one less factors because that particular number above 50 will not be present, and so they will have odd number of factors. So what will happen in this case? This will be off and this will remain on, and there will be no effect for 1 to 50. So how many on? 54, and off will be 46. And this is our answer, and you can check with some few numbers and what is happening over here and verify why it is related to placement of like factors in the positions and how the numbers and factors are reducing due to any situation. But the concept is to understand how this factors is working over in this question.